Hey everyone, thanks for joining us for part 2 of Kubernetes. Today we're going to be going through Helm. My name is Dave Musicant. I work at DraftKings with Garrett Edwards, who's joining us on this call to help walk us through this. Welcome, Garrett.
Hey everybody.
Cool. So what we're going to do is Garrett will first take us through the setup in just a second and talk through the different things that you'll need to install. And then we're going to clear out our cluster from the previous workshop, if anyone has that. Then we're going to make the same stuff as we did before, but we're actually going to make it using a new technology called Helm. So Garrett, if you want to take it away.
Sure. So let's start going through. I've already done the first workshop in the past, so we're going to be starting sort of fresh from this state. But if you just followed the first workshop, you're going to want to, like Dave said, clear out what you've done in there. But just to show you, I've already installed Helm. So that's there. There shouldn't be anything in my cluster, and I'm using a cluster called K3D. So you may be using Minikube, but for this example, there's going to be no difference. And so, yeah, we're going to follow these steps. We're basically going to convert the work from workshop 1 into Helm charts that we can install in our cluster. And then go through some of the features that Helm offers, like installing, updating, rollbacking, and using dependent charts. So basically 2 charts where you only install one, but that chart depends on another chart, and so it also installs that chart for you.
And for the prereqs, so we installed Helm, as you mentioned. We also have Chart Museum installed. It's just a Docker container that you can run, but if you want to just show them that also being installed.
Yep. So this is my Docker. Chart Museum is running here, so I don't have to start that. And these other containers represent my Kubernetes cluster. So we've already done this. Chart Museum is running, but you can run this command if you need to start Chart Museum, which will expose it on your host on port 8282.
And if you've ever used anything like, say, Artifactory to store any sort of artifacts, either Java or .NET type artifacts or Docker images, Chart Museum is similar, but it stores Helm charts.
Yep. The next steps, I've also already installed this Helm plugin, and I've added my local repository to Helm, so it knows about it.
Yep. And the only thing to note there is if you are on Windows, you are going to need to run it in something like Git Bash, so something that has the Unix capabilities to run a .sh script.
Yep, so my cluster is actually cleared out, but you can use these kube control commands if you want to clear out the work from the previous workshop. Make sure that nothing is running in your cluster. And we can run some of these commands and just see that there should be nothing in any of those namespaces.
And if you did already delete your previous one, just make sure you create the 2 namespaces, app-layer and data-layer.
Yep. So let's get started. When you're using Helm, they have a command that allows you to create a new chart. So we can say Helm create. We're going to call this DB application. And we're going to see over here in the sidebar, there's our new DB application Helm chart. And Helm places lots of files into the default chart. So there's an explanation of what all these things do here. For our simple example, we're going to delete almost all these files. So let's go through.
This is a sample. It's basically a sample app that they give you to run Nginx, but we don't need most of those things. So we're just going to delete them, and then we'll add our own files.
Yep. So we're going to open up the chart.yaml, which this is the file that defines basically all the properties of this chart. So the name, version, the version of the application that it's going to be installing, which is separate from the version of the Helm chart, which installs the application.
So you can think of it as like the metadata of the package that we're about to create.
We're going to create some new files. paste in the code.
And basically what we're doing here is, if you remember from the previous workshop, we created a MySQL pod. And we had for that pod a bunch of things like we have credentials. So the username and password for that. We're doing the same thing here, but you'll notice we have some special code in here, which is different from the YAML we had before. That's for Helm. Helm actually allows you to template these things, and you can also build functions. So we'll be taking a look at how those functions work and how we actually pass in the information that gets templated into this file.
So the next step, we're going to change the helpers file that it comes with. And this file contains all those functions that you can use to modify the template that you want to output.
Yep, and this uses a form of Go, is the language that the functions use. And this values.yaml that he's put together here, this is how you actually specify the variables that you're going to actually be placing into those templated files, and which ones can be overridden at the command line and how they can be overridden. Plus, we're also specifying defaults for these. So you can see, for example, we've defined here that our namespace is going to be the data layer. We've also specified that we're going to have a field called MySQL root password. So that's going to be an environment variable, and that we have some secret values for it. If you remember from the previous workshop, we had the same thing, and these are base 64 encoded values of the username and the password. And one interesting thing to note here, we do have this property called env variables. That is something we made up. These are freeform. These are not preset variable names.
Yeah, so next, let's have Helm basically figure out this template and output.
This is not going to actually install anything. When you use the Helm template command, this is actually going to run all of the processing and template replacement so that you can see what it actually would create for you if you were to install it into Kubernetes. And you can see now this YAML looks very similar to the one we did in the previous workshop. You'll notice all of those template variables are now gone. And we actually have, if you look in his terminal output, we actually have a valid YAML now.
Yep. So this next section is going to go into some of the details of how the functions work. There's lots of documentation in here that you can check out. It's a little tricky to read, so sometimes you have to read through carefully, and the dots mean certain things in certain contexts.
Yep, definitely read through those comments because it'll explain kind of how those functions work. But as I mentioned, it uses a form of Go to do all of those functions.
So the next, we're going to take on the deployment.
If you remember and if you remember from the previous workshop, the deployment is where we specify the actual containers that we're going to want deployed into our pods. And as with the previous one, you'll notice there's a bunch of templated information here. And if you look on line 47 in his file here, that's where you remember in the values.yaml, we were specifying the environment variables. Here's where we're actually putting in the values for those things. Yep. And you'll notice again, we're putting in some new values for the functions to be able to pull out and for the templates to use. And the one he's replacing right now is one that gets the label. So what we've done is we've actually created a loop. So if you see where it says range right there on line 52, this is creating a loop that allows us to go through that values.yaml file and add any labels that we put in there so that you could do as many as you want and it will find all of them and add them into your labels. So if you go to your deployment YAML, please, Garrett, and you go to where the labels are specified. So if you look on line 34, you'll see this is how we call our function selector labels that he just created there. So you use include, and then you reference the name of that function, and then it's going to actually go through our values.yaml. So if you want to pop over to that, our values.yaml, and you'll see it's going to loop through all of the labels underneath here, which we only have one, which is app and DB service, and it'll pop it into that section of our deployment.yaml.
Yep, so let's see what the output of this looks like now. Expand this. So you'll see a pretty large YAML came out. These are all of our different files that we have templates of. Helm basically read through all those, replaced anything that it needed to with the specification from our values, called all those functions. So we shouldn't see any of the template code that was in any of these files, and now we have actual values in this YAML.
Yep. And a couple of things I want to call out. So if you can scroll up to where you did the command, please. So you'll see he's actually passing overrides here. So you'll see for the DB username, he's passing the actual base 64 encoded value for root. For the password, he's passing the actual value, which is base 64 encoded of, I don't remember, fake password or whatever we ended up using. But now if you look in the output YAML in his terminal, you'll see that it no longer looks like the previous run, where now the DB username and DB password in that YAML have the proper base 64 encoded. And that's because Helm allows you at the command line to pass in different values to override versus what's in your values.yaml. Cool. So one thing to notice here as we walked through the functions and the values.yaml, if you want to go to your terminal for a second, Garrett, and just do a arrow up so we can see the previous command. So you'll notice here, it's actually very messy to replace that stuff in his values.yaml. So can you go to your values.yaml or scroll down to the environment variables of it? So you'll notice we used an array of items under env variables, which is a nice clean way to nest this stuff, but for Helm, it's actually very bad. This type of complex structure is incredibly hard to override and to use and to reference. So you remember we had all those functions, they're very complex. It's actually hard to maintain and hard to grab that information. If you do have a second, take a chance to go through those functions and look at them. They're really complex in order to be able to pull this information out. So our next step is we're actually going to walk that all back and we're going to actually simplify this, which is the best practice for Helm.
Yeah, so let's go ahead and do that. We're basically going to flatten, like Dave said, all these complicated values that are in lists down to something much simpler.
And you'll notice, even though it's flattened, it's not as, as well representative necessarily of the structure, but you can override all the exact same things that you did before. And you'll notice now our YAML is also much simpler. We don't need to use any of those functions anymore. So he's actually going to replace those functions in the helpers file. So this will simplify everything from we don't need functions anymore. And then in addition to that, our YAMLs become much simpler too.
Yeah, so let's check that what we just did also works. Get a nice YAML output.
Yep. This is going to be much easier for people to work with. So definitely the best practice from Helm is what you want to use with your files. You missed the letter A. Yeah. And now you can see we have the full number of pieces that we need to create the database. So we have our credentials, so we can get our username and password. We have the service, which is basically our load balancer. We have the deployment, so we're going to have our container actually running as well. And now the next piece, if you remember from the previous workshop, is we're going to actually create an external name so that this can be easily reached from another namespace. Yep. And if you can just go to, before you run the command, if you can go to the external name for a second. So one new thing we've introduced here is conditionals. So you'll notice just a couple interesting things about conditionals. One is we can keep this entire YAML from being installed into Kubernetes if it's actually false, the thing we're checking. But another thing you have to note here is if it is false or it's not actually included, so if someone didn't actually put in their values.yaml, the external names.db.enabled, this would blow up if that's all we checked, which is what we're checking on line 3. So we actually have to check each step of the way through that path. So we have to check first that external names exists, then we have to check that DB exists, and now we can actually check the value of external names.db.enabled. And you'll notice here that it does not show at all. So we have the DB credentials, we have the service, we have the deployment, but we do not have the external name. And that's because he ran this with it set to false. But now if he runs it again and sets it to be enabled, which you can see there, it's enabled true. And now you can see we have the external name YAML. So conditionals are a really powerful tool that you can use to not just include specific values, but entire YAMLs.
So the next thing we're going to go through is how to basically package and publish these charts. So when you go to consume a Helm chart, you can publish from your file system, or you can use a Helm repository, which has a listing of all these packages. So we're basically going to push to that chart museum repository that we created. You see it pushed the name of our chart, version 1.0.0, to the local development repo.
Yep. And it packaged it up and compressed it as well. And then next command is actually important. Even though we're using Helm's plugin to push it, Helm does not actually update its own listing of what's in those repos. So we have to do the repo update every time we push. And now you'll see our local development repository, which is our chart museum that we're hosting locally, does in fact have the MySQL DB app, and it has it at version 0.10.
Here we're just making sure that I have these namespaces created in my cluster. And then we can go ahead and install that chart that we just published.
Yep, and a couple of things to notice before you run this, you can just put the command there. You'll see we're doing install db-app. Notice that's different than the name of the chart package itself. We're creating what's called a release name. So every time this chart is installed into Kubernetes, if you give it a different release name, it will actually install a whole number of different instances of all the things that you've asked it to install. So that release name is a Helm specific thing. And so Helm will actually create what's called a release, which, as we'll see later, we'll be able to update and roll back and delete.
Yeah, exactly. So if you wanted to install the same chart twice, you can do that by specifying different release names. So let's go ahead and run this install. Let's check out what the cluster is doing. So we see we have this pod came up. You can check on the services. See the services there. And now, instead of just having to check each individual Kubernetes object, we can use Helm actually to say what's installed, representing all those things that we've developed here to run this application. So we see Helm says DB app is installed. It's revision 1, the time we did it, what its status is, the name of the chart, etc.
And an interesting thing to note here is the revision is not tied at all to the app version. So we'll see that in a little bit, that all the things we do to this when we upgrade it, when we install it, etc., that's going to change the revisions. That's from Helm's standpoint, not from Kubernetes standpoint.
So now we're going to do some modifications to this chart and change the labels. So let's see what we have installed right now, what labels are on our pods. We'll see we have this string here.
Yep. So you can see we have, I think, 4 different labels. One of them, if you look, is the app DB service. That's the one we created. So if you go ahead and open up the deployment and you find the place where the labels are done, we're going to add an extra label. You can name this whatever you'd like. Doesn't technically matter. Just make sure you put in an extra label there.
Yep, and now we're going to bump the version of the chart.
Yep, and this part's actually very important. So in Helm, there's actually 2 version numbers here. One is the app version, one is the chart version. The chart version is the one that needs to be updated for Helm to push another version of this chart. It tells Helm that this chart has actually changed.
So we're going to go through the series of pushing, updating the repo, just double checking what's in there. So we see we now have version 0.2, which we just created and pushed. And now let's upgrade what we have in Kubernetes to this version of the chart.
Yep. And an important thing to note here, you'll see right after the word upgrade, we're still using DB app. If we changed that to say something else, it would not actually upgrade what's already there. It would create a new release.
Yep, so also notice here we have revision 2, which this is what Helm is tracking here. Let's check our pods. Pod is up. We see another label in here, extra label equals Helm updated.
Yep, and actually, can you do a quick thing? Can you check the pod just to show them something without checking
Sure.
the labels? And you'll notice something interesting here, which is that this pod actually was not changed. I mean, sorry, the pod was changed. Sorry, check the service. I apologize. Okay, you'll see the pod was changed because we added a new label to it, but you'll notice the service was not. It actually was last changed 3 minutes ago. That's because even though we upgraded the entire chart, Kubernetes is smart enough to see that we made no changes to the other YAMLs, and therefore it doesn't actually do anything to them. It only applies the actual changes we made.
Yeah, so next, we're going to use another feature of Helm where we can roll back to releases that Helm already knows about. So let's check in this case, if we were to roll back, we're going to lose that new label that we've added. So let's do that. We're going to roll back to revision 1.
Yep.
Helm says, great job.
Yep, and you'll notice he rolled back to revision 1, not to an app version or a chart version.
Yep. That label that we added in version 2 is gone, since now we're basically at the state of the cluster when we installed this first revision of that Helm chart. Helm's also tracking this, so we can say, what was the history of this? We see that revision 1 was installed with this version, revision 2 installed 0.2 of the chart, but now we've actually rolled back. So the third revision is back to 0.1.
And that's really important to note is it's keeping basically an audit history of everything. So even though you rolled back to revision 1, it is not one revision. It's actually a totally new revision, even though it's exactly the same state as what you had in revision 1. And that's why we now have 3 revisions.
Yeah. So another really awesome feature of Helm is the ability to just uninstall releases. So if we wanted to go through and actually get rid of all these things, we have to write a bunch of Kubernetes commands. But instead, Helm is tracking and managing all these resources. So we can just tell Helm, please uninstall DB app. We're going to see all these things are gone. And then if we also check the Helm history, we'll see Helm forgets about everything about that release, basically everything about that chart that you've ever installed.
Yep. And so an interesting note here is if you did want to keep the history and be able to roll back, but you wanted to remove all of those things from being run inside Kubernetes, what you could do is put conditionals on all your YAMLs, just like we did with the external name, and then run a Helm upgrade where you actually turn them all off. You will then get a new revision, so you'll be able to roll back to a previous revision to turn them back on later, and it will keep all that history.
So next, we're going to use one of the features in Helm that you can actually combine different charts in a dependency type relationship. So we're going to add a new chart. We're going to say in the same project, Helm create a REST application. So we're going to see over here, there's another folder. We're going to do something similar and delete almost all the things that this comes with. Those are all gone. Clear out the default values. And we're going to update our chart.yaml.
And let's just take a look at this real quick. So you'll notice something new here versus the other one. We now have a section called dependencies. And you'll notice the dependency is the chart we just created a minute ago, which is our MySQL DB app. And you'll notice we're specifying a version, and then we specify a repository. And if you put an @ symbol at the front of it, it knows to look for that repo by name. So you remember we defined that in Helm so that it knows what the local development repo is. And then we also have a condition here. So you can put conditions on dependencies, and it says only install this dependency if MySQL DB app.enabled is set to true. So now he's going to run an important command that you need to do. Helm will not automatically pull down and map your dependencies for you. You have to actually run this command, which you'll notice he now has a charts directory, and it has pulled down the actual version of that chart. And it's now sitting inside the REST app.
So we're going to put some content back into our values.yaml.
Yep. And an interesting thing to note. Yep. Sorry, Garrett. An interesting thing to note here. You'll notice we have the same values.yamls that we had in the DB app, but they're actually prefixed by the name of the chart itself. And you'll notice 2 important things to note here. One is all the things you want to set on a dependent chart have to be prefixed with the name of the chart. So they're underneath that. But the other thing to note about it is it's the name of the chart, not the name of the Helm release.
So we're going to push this new chart to our repository, like we've done in the past, Helm repo update. And now we should be able to Helm install our new chart.
Yep. And an interesting thing to note here, this chart has nothing itself yet. All it has is the dependencies. So we should end up in exactly the same state we had before with the MySQL DB app. However, it does not see the MySQL DB app installed for Helm. It sees the REST app installed for Helm.
So next, we're going to take advantage of the ability for Helm to disable dependencies. So we go ahead and uninstall this REST app.
And the nice thing here, as Garrett was mentioning before, the uninstall will install not only our REST app, but any dependencies it had as well.
Yeah, so we can see that in the output of these commands. REST app didn't have any resources, but Helm uninstalled the resources that were associated with the MySQL app. So now we can run that same install, but we're going to disable the MySQL DB app. And as we noticed, there are actually no resources associated with this REST application chart itself. It's really just installing the DB application. And so if we disable that, we should see no resources in Kubernetes at all, which we do. But the interesting thing is that Helm is still tracking this release. All it cares about is that you installed a chart named REST app. Whether or not it has resources, it doesn't really care. It's still going to say you installed this. It's the first revision, the name of the chart, etc.
And that's that piece we were talking about before, which is if you wanted to be able to continue tracking it through revisions in Helm, but you wanted to actually make sure nothing was in Kubernetes, you can use conditionals like that, and it will basically tell Kubernetes not to have any of those things deployed.
Now we're going to disable part of the MySQL DB app. So we're going to see the pod is there, but we should have disabled the service, so there's no resource there.
And the nice thing to notice here is how incredibly fast and easy it is to change, install, uninstall, roll back a number of things. Like he's got, I think we had like 4 different things all being installed, and they're all being installed as a dependency, and it's just one command for each one of these steps.
Yep, so just like that, uninstall the REST app, everything's gone. Well, the command doesn't report everything's gone yet, but it says the pod is terminating. So this will be on in a second. We're going to take some more steps. So we're going to add some resources to the REST application. Let's open up this new file, put some content in.
And this is the same REST app from the previous workshop. We're just adding templating to it, same as we did for the DB app.
Yep. We're going to add our ingress. We're going to add the deployment. And lastly, we're going to add this file for the service.
So if you remember from the previous one, we're adding a REST application that's actually going to reach across the namespaces to the MySQL database. It'll put some data in there, and then it'll read it back out. And you'll notice again, we're using a nice flat structure, so no arrays or lists anywhere in here.
So I'm making this modification only because I'm using a different cluster technology. But if you're using Minikube, you could have just left this as simple REST. We're going to update the chart YAML. It's going to be now version 2. And since we've actually changed the application, now is a good time to upgrade that app version, which represents the stuff that you're actually deploying here. What is the level, the version of the application, and not what is the version of the Helm chart.
Yeah. And an interesting thing to note, the chart version is semantically named, so you have to use semantic versioning for that. But app version is freeform, so whatever you want to use for that, you can use for that version.
Yep. So now let's go through the process of packing and pushing this Helm chart into our repository. Let's update. Pretty much always want to do those two steps back to back. And let's finally install this REST application. So let's check that we have some resources. Got the REST service, the DB app services are there. The REST application pod is there. And hopefully similar to the last workshop, I've already set up my hosts files, so we should be able to access this page here, DraftKings Kates, which is going to send to the application running in our cluster. So we say, got first value.
Nice. And it installed everything exactly as we had in the first workshop, but this time we did everything in a nicely packaged manner, so that now if he wants to make any changes, instead of having to go through installing and uninstalling a lot of YAMLs, he can do it in one command.
And that's it for the hands-on stuff. Yeah.
Yeah, if you want to take them through a couple of the key takeaways.
Sure. So we went through how to use charts. There's some naming conventions, lowercase names. You can use dashes between the names of your charts. Values should be camel cased. Helm has some documentation for best practices of labels, which you can read if you click on this link. And one of the most important things that we talked about is the YAML structure at the beginning of the workshop. So if you're using any YAML structures that contain lots of lists, overriding anything in those lists becomes really difficult. So you want to flatten your YAML name properties as best you can. So just like in this example, you don't really want to have to go and set each one of these. Instead, you can set them by name. And this also allows any consumers of your Helm chart to have a much easier time. They don't have to know anything about the ordering. If it's special, they can just directly override things that they want to override when they're installing.
Yep. And the other thing to note too is if you use a list, you actually have to override every single property in that list. You can't override just one because it replaces the entire list with whatever you've passed in. Great. Thanks so much for doing this, Garrett. This was fantastic.
Yeah, thanks for having me.
Yeah. And next up, we're going to be doing a part 3 of our Kubernetes workshop. So we'll be looking at linting, using schemas to validate our Helm charts. We'll look at integration testing, and then also the way you can use health checks with Kubernetes as well. Take care.
See you later.